This video is about review for derivative. Calculator allowed. 1a, let fx equals this. The following diagram shows part of a graph of f. There are x-intercept at x equals 0 and x equals p. There is a maximum at a where x equals a, and a point of inflection at b where x equals b. Then find the value of p. Since this problem we can use a graphing calculator, I will show you on the calculator.
First of all, we will put a function into the calculator, y1. Then we go to graph. From this graph, you can figure out this maximum point and also this x-intercept. So we go to second trace. Let's calculate. First of all, we want to figure out the x-intercept. That's 0. So I press this 2, 0. Left bound means we need to put this arrow on the left side of this x-intercept. So we move the arrow to the left. Yeah, this is a left bound, means on the left side of this x-intercept. I will put the enter. Right bound, so keep moving on the right side of this x-intercept. I will put the enter again, then enter. You could see your answer will be 2.73. That will be the x-intercept. Remember, we need 3 significant figures. Now we can work out this maximum point. Still go to second trace. Maximum, that's 4. So press 4. Left bound, still make the arrow on the left side of the maximum point. Enter. Then move to the right side of the maximum point. Enter. Then enter again. This will be the maximum point.
For 1c, write down the rate of change of f at a. We know a is a local maximum value. Therefore, the rate of change, which means the derivative of fx at a, equal to 0. Because for derivative means the slope of a tangent line. For 1d, find the coordinates of b. We know this b is a reflection point. According to the definition, the second derivative of fx equal to 0. So we will set up on the graphing calculator the second derivative of fx equal to 0 to figure out the x-intercept. That will be the x-coordinate of b. Now, I will show you how to use graphing calculator to figure out the inflection point. We go to y. We will put the derivative into y2. So go to math. Derivative will be 8, so I press 8. This will be x. We do the derivative of y1. So we go to variable, y variable, get the y1. Then for this x equals to x. This will be the first derivative of y1, which means it's a slope of a tangent line. We want to get the second derivative of y1. Therefore, we do math find the derivative, that's 8 again. Here's x, but this time we need to put y2 because we do the derivative of y2. So variable, y variable, function. Then here's y2. Then get this is x. If you go to graph, you will see 3 graphs. It's hard for us to decide which one is which one. Therefore, we go back to y equals. You can clear this equal. I see enter. Then the graph won't show the y1 and the y2, only show y3. For the y3, since this is a second derivative of fx, we want to figure out the inflection point, which means the second derivative of fx equal to 0. I need 0. So we do second trace, 0, enter. We know the x is greater than 0 from the given graph. So we need this point, this left bound. I will move a little bit closer to this x-intercept. That will be left bound. Left bound means it's on the left side of x-intercept here. So we do enter. Then keep moving to the right side of this x-intercept. That will be right bound. I put enter. Enter. You will get x equals 0.9. That means x equals to 1. For 1e, find the rate of change of f at b. I will show you using calculator how to do this. So we go back to y1. y1 is original function. The second derivative of original function, that's y3. y2 means the first derivative of fx. We are looking for rate of change of f at b. Therefore, we need to use the first derivative. We quit. So you can go to y2 variable. Here's a variable. I need a y2. We know the x equals 1, so we put the enter. That will be 6. Another way to do this will be math. We get the derivative, that's 8. Then this time, you need to put the y1 because we put the original function into y1. Then put over here x equals 1. You will get the same answer. It's really up to you which one you got to use it. For the 1c, find the rate of change of f at a. We know the a is a maximum value, therefore it will be equal to 0. Rate of change means derivative. Derivative means slope of a tangent line. It will be equal to 0. Now let's go to 2a. Let f of x equals 1 over x minus 1 plus 2 for x greater than 1. Write down the equation of a horizontal asymptote of the graph of f. How you get the horizontal asymptote line? We need to do the limit as x tends to infinity of 1 over x minus 1 plus 2. This will be the horizontal asymptote line for rational functions. So we plug in infinity into this x. We know this is the rule. 1 over x equals to 0. Therefore, this one will be equal to 0 because infinity minus 1 still infinity. 1 over infinity equals 0. Then 2 will stay because this is constant number equals 2. We will write down y equals 2. This will be the horizontal asymptote line. For 2b, find the derivative of fx. Derivative of fx means I will change 1 over x minus 1 into power form. So we get the x minus 1 to the negative first power plus 2. Then we do the derivative. We got to use power rule. So drop down negative 1 times x minus 1. The negative 1 minus 1 will be negative 2. Then we do the derivative of x minus 1. It will be 1. Derivative of a constant number will be 0. We don't have to write down. Therefore, we got negative 1 over x minus 1 squared. This will be the 2b. For 2c, let g of x equals this. For x greater than equal to 1. The graph of f and g have the same horizontal asymptote line. Write down the value of b. For this g of x, I can write down a over e to the x power, then plus b. For this function, we still can use limit to figure out the horizontal asymptote line. Therefore, limit as x tends to infinity of a over e to the x power plus b. E to the infinity's power still infinity. A over infinity, definitely this would give you 0. When you plug in x equals infinity into these expressions, a over e to the x power, it will be 0. B is constant, will stay. Therefore, you can get the b. Y equals b will be the horizontal asymptote line. Because f and g, they have the same horizontal asymptote line. In other words, b equals 2. Now let's go to 2d. Given that derivative of g of 1 equals negative e, find the value of a. We already know the b equals 2. Therefore, we do the derivative of g of x equals a e to the negative x power plus b. We do the derivative. We will get the a times derivative for e to the negative x power will be e to the negative x power. Then don't forget to the chain rule of this negative x. That will be negative 1. B is constant number. Derivative will be 0. So you will get negative a e to the negative x power. For the given information, we plug in 1 into this derivative function. You will get negative a times e to the negative first power is equals to negative e according to this given information. So we get the negative a times 1 over e equals to negative e. Both multiplied by negative 1, we turn into positive. Then try to get rid of this e by multiplying by e both sides. Therefore, you will get a equals e squared. So we get a equals e squared. Let's go to 2e. There is a value of x for x between 1 and 4, for which the graph of f and g have the same gradient. Same gradient means derivative of fx equals derivative of g of x. Then find this gradient. We already got the -1 over x minus 1 squared. That is the derivative of fx. Let's work out derivative of g of x. We already got the a equals e squared, so we plug in e squared times e to the negative x power. B is 2. We do derivative for this function. We multiplication of a power, we can add exponents. So we got the e to the 2 minus x power. We do derivative for that. You will get the e to the 2 minus x power. Then use the chain rule to do the derivative of 2 minus x. That will be -1. Derivative of a constant number will be 0. So we get negative e to the 2 minus x power. We try to use equation solver or 0 to figure out this x. Therefore, always change the equation into equal to 0. I move to the left side. You will get -1 x minus 1 squared plus e to the 2 minus x power. First of all, we will put this equation to y1. You can go to graph, then get the 0. Second trace, get the 0. Since we are given x between 1 and 4, therefore we will move this arrow to the left side of this x-intercept. We put enter. Then move to the right side of this x-intercept, enter, then enter. They give you x equals 2. Or you can use a equation solver. We put the math and then use the upper arrow, go to solver, enter. Use a variable, y variable, function y1, then put enter. Estimate, you can put 2.5 because remember the x value between 1 and 4. Then I do alpha, enter. 4.5 is out of 4, so it's not good. You can say it's 1.5. Then do the alpha, enter. See, they give you x equals 2. We got the x equals 2. Then we plug in either -1 over x minus 1 squared or negative e to the 2 minus x power. To figure out this value, it will be this gradient. So y equals -1, 2 minus 1 squared equals to -1. Now let's go to 3a. Consider the curve y equals natural log of 3x minus 1. Let P be the point on the curve where x equals 2. Write down the gradient of the curve at P. We got to do derivative of fx. You will get derivative of natural log of 3x minus 1. Derivative of natural log, you will get the 1 over x. So we get the 1 over 3x minus 1. Then using the chain rule to do the derivative of 3x minus 1, you will get 3. So we get 3 over 3x minus 1. Then we plug in 2 into this derivative function. You will get the 3. 3 times 2 minus 1. That's 3 over 5. In other words, the gradient of the curve at P will be 3 over 5. Let's go to 3b. The normal to the curve at P cuts the x-axis at R. Find the coordinates of R. First of all, you will get the slope of normal. That will be -1 over this 3 over 5. You will get -5 over 3. As we know, the slope of any line times the slope of its perpendicular line equals -1. After we got the slope of this normal, that is -5 over 3, we can also get the coordinate for this P. P will be 2. We plug in 2 into the original function. You will get the natural log of 3 times 2 minus 1. Get the natural log of 5. Natural log of 5. Then we use y minus y1 equals slope x minus x1. You will get the y minus natural log of 5 equals -5 over 3 x minus 2. We know this R, that's the x-intercept. Therefore, we will set up y equals 0. We plug in here. You will get the negative natural log of 5 equals -5 over 3 x minus 2. You can use equation solver to get the solution. Before you put it into equation solver, remember get equal to 0. You will get the negative natural log of 5 plus 5 over 3 x minus 2 equal to 0. Then using equation solver, you will get the x equals 2.97. Let's sketch the graph on the given graphing paper. First of all, remember when you put into your calculator, y1, that's original function, y2 will be derivative. Only highlight the y2 so that you get the graph of derivative of y1 only. Make sure your window will be exactly as the given graphing paper. X will be between -2 to 2. Y is from -7 to 5. Then try to get the y-intercept, x-intercept, and minimum and maximum value. Therefore, we got the y-intercept that will be -0.84. Just estimate, over here. Then for the minimum value, that's 0.707, -1.8. So suppose this is a 0.7, then -1.8 will be here. Just estimate. Maximum value will be 1.5 and 4.8. It's here. Then for the 0, they go to 1.1 is here. And 1.8 will be here. After you get these key points, after you figure out all the key points, the very, very critical one is the domain and a range. So you need to put the x equals -2, get the y equals -0.01. That will be like very close to this 0. That will be the very left point. Very right point, when x equals 2, it goes to -6.6. So -6.6 over here. You will get the line like this. Then you connect all these points according to the shape given by the graph. Now let's analyze the correct answer. First of all, they said avoid A1 for shape that must have the correct domain. So you have to make sure it's from -2 to 2. Correct range will be from -6 to this 2. That's the reason I plug in x equals -2 and x equals 2 to figure out the domain and range. A1 for minimum and also 1 point for maximum. Then for intercepts, that's add another point. Altogether, it will be 4 points. So make sure when you sketch any graph for IB exam, it's a domain range you need to consider. That means for this graphing paper, if they give you very left point, what is it? Very right point, what is it? You need to figure out the value for that. And also the key points, that means all intercept. And also the turning points, or its maximum points or minimum points.